Hello, everybody. In our last episode, we talked about how the British satellite communications company Inmarsat had discovered, much to its shock, that it had in its database information suggesting that MH370 had traveled for another 6 hours after disappearing from Malaysian military radar. That itself was shocking enough. No plane had ever behaved in this way before. But what they found next was even wilder. Now, remember, this data was strictly about maintaining satellite communications. It had nothing to do with navigation or keeping track of where the plane was in space or time. But it turned out that by looking at this data quite carefully and being very clever, Inmarsat scientists were able to extract clues that gave them a sense, quite a precise sense, of where the plane had gone. But there was a catch. The information didn't just tell them one spot where the plane went, but actually two. In today's episode, we're going to talk about why that was and what the scientists hope to do to get around that problem. Hi, everybody. Jeff Wise back with you with episode 5 of Deep Dive MH370, an investigative podcast where we peel the onion, going through all of the evidence step by step of what happened to the plane, what evidence was gathered, and what it all meant. I originally put this podcast together with Andy Tarnoff starting in 2023. We've since gone our separate ways, and I no longer have access to the original YouTube page. So what I'm offering here is a re-edited and remastered edition of that podcast. For more information about each episode, please visit the show page at deepdivemh370.com. You can ask questions, you can sign up for a free newsletter, and if you take a paid subscription, you get exclusive early access to each episode. As this episode starts, I'm talking with Andy about how the members of the public and the media learned about this information from Inmarsat and how we struggled to make sense of what it meant. And we really didn't understand it. We didn't know we'd never heard of this kind of data before. We didn't know what it was. And in the days and weeks that followed, the Malaysians kind of slowly leaked out information, kind of gave us clues. Some of what they told us later turned out to be kind of inaccurate or just slightly misstating what the actual nature of the data was. But by the end of that first week, we were starting to piece together what was going on with this data. And so, as we talked about a little bit last time, this isn't data like telling, like we talked about Air France 447, where it was sending these packets that were telling the company on the ground what was wrong with the plane. That wasn't happening here. What was happening was somebody or somehow this SATCOM system had been turned back on shortly after the plane left Malaysian military radar, and it turned on, and as it turned on, it sent a signal up to the satellite, and it basically said, "Hi, I'm here." It's called a handshake signal. It's basically establishing communication so that when the user is ready to send a text or make a voice call, the system will be ready to make that connection. And so there is no transmission of like, "Hi, I'm at such and such a location. My engines are burning fuel at such and such a rate." It can do that kind of thing, but that part was turned off. It was just the basic handshake protocol that was being
Yeah,
enabled.
the big question that everyone was wondering then was, will this information tell us anything about where the plane went? And the answer is yes.
Right.
Had Malaysia Airlines paid for the advanced service or the upgraded service instead of the cheapest one, there
Right.
probably would be no mystery here because we would know exactly where the plane went.
Right.
But instead, we're stuck with just this vague information about ping rings.
Right. So the Inmarsat scientists said, okay, we have this signal. The signal does not have any embedded GPS information that will tell us where exactly this plane was. But it is telling us something. So let's look at this data and what does this data tell us? And it turned out that there were a couple of things, and the one we're going to talk about today is the simplest kind. It's called the burst timing offset, or BTO. We're just going to call it BTO. Or maybe timing data. It's a bit of jargon, but it's useful to know because it's very important in this case. The BTO is a measure of how long it took the plane to respond when the satellite said, "Hi, are you there?" And because
Yeah.
light travels at a certain speed, and because there's also a certain amount of time that it takes the satellite data unit to process its own inner workings and then reply. From this time lag, basically the Inmarsat scientists were able to derive a distance from the satellite to the plane.
Now, this is not, they didn't invent burst timing offset or BTO. I mean, that's,
This was something that, that
it's a
satellite
science,
communications engineers were interested in ever since they started building satellite communication systems. They're trying to make sure that their system works. They want to understand how their system works. They want to make sure it's within the parameters as they designed it. So they're logging down various parameters of the signal like this. The other one that's important is the frequency offset, which is similar to the time offset, but it just measures how the difference in the frequency. We'll talk about that more in a future episode. Basically, they want to know, is this signal within the parameters that we designed it? They didn't intend it to be used for this at all. But
I was going to say, this has never been done before, or at least for this purpose, this had never been done before.
It had never been used for this purpose, but there is a very interesting connection to Air France 447, which we've been talking about for a while now, which is the case that had happened back in 2009. When that plane went missing, the scientists at Inmarsat said to themselves, just in case planes go missing in the future, it might someday be useful to have this kind of data. So we used to just kind of, it would come through the wires and we just throw it out. Now we're going to start recording it and logging it for every single user. We're going to start storing that data. And they had done that only recently because, the final report in Air France 447 was 2011. So it wasn't until 2011 that we really understood what happened in that case. So just for a few years, they had started to record this data that turned out to be extremely useful. And I don't know if anybody, I don't think anybody knows, if anyone outside of Inmarsat knew that Inmarsat was recording this data. That will be an interesting point to consider later. But for now, let's just say that as this case was unfolding back in March of 2014, we journalists who were covering it were starting to realize what Inmarsat knew, what the Malaysian authorities knew, and what it implied about where the plane might have gone.
There's some heavy-duty math about to happen here. But the Inmarsat, the mathematicians, they took these 7 hourly pings and they derived some valuable information that allowed them to make some conclusions about where the plane went, and they allowed journalists to make some determinations about where the plane went. And they didn't necessarily match, but it's based on the same data.
Right. Well, once there were a lot of people, journalists and also just interested bystanders, people on the internet, who were poring over every word that was coming out of the authorities and trying to figure out what did it mean. And when the authorities tell us, oh, the plane must have done this, the plane must have done that, are they right? Let's double check what they're saying because, this being the world that it is, we don't necessarily trust the authorities. We want to sort of trust but verify, right? So we want to check what they're saying. And I was one of these people. I'm watching the story and they're telling us, they're saying that we have these 7 rings and they have to do with how far the plane is from the satellite. And if you project that fact, if you know how far the plane was from the satellite, then you know that it must have been, it couldn't be just no longer anywhere on the Earth. It can be somewhere on the Earth. And mathematically, it turns out to be a circle. If you hold a string and I hold the other end of the string, and I'm at the end of that string, I could be anywhere in a circle, right? It's like a compass and pencil back in grade school, right? And so for each of these moments in time when a ping was recorded and the burst timing offset data was recorded, we have a distance which translates into a kind of an arc that's on the surface of the Earth, or actually maybe 35 or 40,000 feet above the surface of the Earth, but it's still an arc. And so that isn't the track that the plane followed, but it is the set of all possible places where the plane could be at that moment.
Right. And the reason it's an arc as opposed to a giant circle is because there are physical factors that would be limiting the plane from magically appearing on the other side of the Earth.
Right, exactly.
Like you can rule out a whole bunch of stuff, and with the amount of fuel and the time, I mean, it's going to be in a certain vertical north-south area.
Right, exactly. And so before too long, we were in possession, we meaning the public, was in possession of a set of 7 rings or arcs, depending on what you want to call it. And each of them was recorded at a certain time. And we were able to play with it. One of the great things that, we're living in a modern age, we now have access to Google Earth, and it has these incredibly powerful tools that you can use for free. You can draw circles and arcs and lines, and you can do all kinds of geometrical experimentation in 3D, which before you would have needed a supercomputer. So this is one of the great things about the internet, is that people were coming together on the internet and sharing ideas. And I kind of got involved in all of this because of this burst timing offset data. I had realized that this chart was actually telling us something that nobody was talking about yet, which is, I talked to an Inmarsat official, and they said that each of the rings was larger than the previous one, meaning that the plane was steadily moving outwards away from the satellite. And that immediately dramatically reduced the range of possibilities. It meant that the plane couldn't have gone towards the satellite, and it couldn't have gone further away from the satellite than the final ping arc. So it must have traveled within this kind of corridor defined by the innermost and outermost arcs. So I got very excited. I put this on my website. People took a notice. People started trading information on it. And this kind of gradually turned into an informal group of people trading information. And we even wound up giving ourselves a name. We called ourselves the Independent Group. And there was a lot of very useful science that was being done. Some of these people really know their stuff. They were like satellite scientists and signal scientists. And people were really quite knowledgeable in sharing their formulas and their work.
As sophisticated as this is, it's even a little bit more sophisticated, because even though these hourly pings should have happened hourly, they didn't necessarily happen hourly, because there were some calls coming in. I was wondering if you could explain that a little bit as to why these 7 pings were not equidistantly spaced.
So one of the things that was kind of inaccurate that we were told at first was that this plane was sending hourly pings, as you alluded to. And that's semi-accurate, because the way the system was rigged to work was that the system would turn on, the system would say hello to satellite, and then the satellite would say, hello, we're here to take your call when you're ready. Now, if that never happened, if the user on the ground, or in the air in this case, never did make a call or send a text, there'd be a timeout, as you happen, with websites where, like, if you don't do anything for a while, they say, hey, you're still there, I'm going to log you off. In this case, the system waited an hour, exactly 1 hour, and it said, hey, I haven't heard from you, are you still there? And this would generate a ping, and the plane automatically would say, yeah, I'm still here. I still haven't got anything for you, but I'm still here. Now, what happened was, twice during the span of these 6 hours, Malaysian Airlines, wondering where its plane was, called the plane. They only did this twice, which I don't know, maybe...
That's it?
That's only it. That's it. That's all. They made 2 satellite calls. And,
I mean, if I'm Malaysia Airlines, I may call back a couple times, but
what they didn't realize was that even though nobody answered, the system was engaged. Now, Inmarsat, looking at the data later, was able to say, oh, actually, the signal went to the plane. The plane's telephonic system was engaged, and just it rang, but nobody picked up. So everything
such a bummer,
was working.
because
Isn't that crazy?
I mean, had they known this, and then they would have been calling every minute for the next 6 hours, you would have had more ping rings. You
would have actually had less. because those calls didn't generate.
Oh, those interrupted the ping ring.
They interrupted the ping rings, and
so thank you, Malaysia Airlines, for
not calling
twice.
More. Actually, it helped. So
insane. But I'm sorry, go on, please.
You've got like a gap of like an hour and 20 minutes, and then you've got another gap of like an hour and 10 minutes, because the counter was reset, and so it's not quite even. But for purposes of, it's not completely inaccurate to say there were hourly pings. They were basically hourly with 2 exceptions. Okay. So, but once they had this, they set about their mathematical minds to think, okay, so can we tell? What can we tell from this data? Like, these are clues. What can we learn from the clues? What information can we extract?
So let me make an aside here. All right. So this is like the Friday after the press conference at Inmarsat. They're explaining all this stuff, and at this point, you're basically already a regular on CNN. Mm-hmm. You've got some inklings of what's going on here, and you're trying to explain this. I'm assuming that went over like a lead balloon.
I got very excited. Because I'm like, I just
Right.
figured out something that nobody knows, or at least nobody outside of Inmarsat, or nobody's talking about on TV, which is that we now have a much, much narrower idea of where this plane went. It basically flew either over the Indian Ocean and crossed the coast of northern India and then went to like towards Nepal, or it went somewhere into the southern Indian Ocean. At the time, we thought it went over the tip of Indonesia, but that's actually turned out not to be right. But we had roughly an idea of where it went. And I took this to CNN, and I realized like they hadn't hired me to be a reporter. They had hired me to be a guy who like answered questions on camera. They weren't looking for me to break news for them. And so I went around and I could not get them interested. And I actually wound up trying to talk to Don Lemon about it on air. And he was like, what?
That must
like,
have been awesome.
Yeah, it was really...
I got to find a clip of that. If I can find a clip of that, I'm putting it in this podcast. Because I can only imagine you talking to Don Lemon, trying to break this down in 2 minutes on that show.
I was so excited.
But they probably were starting to think you were a little crazy. But you're not crazy, because if you drew these lines a certain way and you take into consideration that planes tend to travel at a constant speed,
right,
you could actually get a chart of where this plane went.
A lot of people, including me, once we had the ping rings and once we had Google Earth installed on our computers, we started playing with it. And if you draw a line from, because remember, the Inmarsat data started 3 minutes after its last known radar location. So we basically knew on that first arc where it was on the arc. So you know the starting
where it
point.
Started.
And from there, you can draw various straight lines to the final arc. And you can sort of see, well, which ones generate. And as I said, the distance between these arcs is equivalent to its speed. So if two of these arcs are 300 miles apart, and you imagine the plane was going 500 miles an hour, then you would have to have sort of an angle between one arc and the next. And the thing that's important to realize is that you can actually generate, for every imagined speed, you can have two lines. One that goes to the right and one that goes to the left. And if you extrapolate these outward, you get two equivalent routes. For any given speed, you wind up getting two routes. And when you look at it, you quickly realize that this set of ping rings actually seems to want to tell you how the plane was flying and where it flew. Because the planes tend to fly straight. Like commercial airliners like the 777 are designed to fly high and fast and straight, because that's efficient. There's no reason to be dawdling around. You're not tooling around in your motorboat looking for fish. You're going from here to there, and the way to do it is straight and fast and high. And if you assume that this plane flew in that way and you start drawing lines on the chart, you'll quickly notice that there's certain lines that match the speed of a 777, the speed at which a 777 typically flies. And you don't have to make curves or bends or anything. It just wants to go at that speed. And so very quickly, a lot of people observing independently, and the authorities themselves, you can approach this a lot of different ways. Mathematically, with a ruler and pencil. However you approach it, you get the same answer. This plane winds up in a very small area of either the southern Indian Ocean or Kazakhstan.
So backing up for just a moment,
Sure.
if I may. Until I fully understood the science and the math behind this, I would have thought that perhaps someone who is trying to abscond with a plane may not be flying in a straight line, may not be flying at a constant speed. They might be squiggling around or trying to evade. But what you're saying is these ping rings validate that it was traveling in a straight line.
They match a scenario in which the plane is flying at a straight line. And I think a really important point to make, and I think a lot of people miss this, and it's absolutely bedrock crucial, is that everyone assumed that whoever took this plane would have no idea that Inmarsat was recording BTO data. Even people who are satellite communications experts in other parts of the world wouldn't know that Inmarsat was recording this BTO data. So there'd be no reason for someone to fly, a curving flight path with different speeds, accelerating and slowing down, to avoid, to make it look like they were flying straight when they were really flying curved. Because you would have to imagine like someone of almost godlike, intelligence and perception and knowledge of what Inmarsat was doing. And
so that's a little foreshadowing, Jeff, because one of the reasons people think that your theory is cockamamie is because they say nobody knew that Inmarsat had this data. Nobody knew that Inmarsat would be able to interpret this data.
Right.
That's kind of
that's
come
a little
together.
Foreshadowing. We'll get to that.
Yeah.
It is. So
but it's notable, though.
It's an important question to ask. Would whoever took this plane know that this, first of all, how to turn on, like, did they even know that the system was on? Because don't forget that when we first heard about this Inmarsat data, we assumed that the system had been left on. And only much later did we learn that it had been turned off and back on again. So would
that's going to be a good one.
And so that's a very good one. But
pilots didn't know how to do this.
Pilots do, well, we're going to talk about that. But the point just being is that it's very hard to imagine that whoever took this plane knew that Inmarsat was recording this data that would later allow them to draw these rings that would later allow them to deduce where the plane went. And so you wouldn't imagine that someone would fly a curved course just for the sake of being crafty and tricky and trying to get away. I mean, listen, if you believe the idea being, look, we did see someone turn off all the electronic data and do a hard 180, which implied that they were trying to be evasive, trying to get away, trying to steal this plane in a way that was sneaky and elusive. And then they flew off of Malaysian radar. This is what's so perplexing. This is what I really want people to think about. Why did someone who seems to have worked so hard to get away now turn on this device that's acting essentially like a tracking device?
It's like they left breadcrumbs.
Yeah, it's almost like they're leaving a trail of electronic breadcrumbs. They're leaving a clue to where the plane went. Why would they do that? Now, an obvious answer would be, well, they didn't know that they were leaving a trail of breadcrumbs. Fine, great. They didn't know they were leaving a trail of breadcrumbs. That also implies that they wouldn't try to leave a sort of tricky trail of breadcrumbs.
And that we are going to get to, and that's when this thing gets super crazy.
Right.
But what I did want to say was, if you believe in the concept of ping rings, and pretty much all the authorities believe it, because that's exactly why they picked their search zone in the southern Indian Ocean, then you have to conclude that after 6 hours, that flight ended in the southern Indian Ocean or somewhere in Kazakhstan.
Right, exactly. And that's what they did. And the authorities said as much. They said this plane is either in the southern Indian Ocean or it's in Kazakhstan. And they reached out to Kazakhstan. And
how did that go?
I don't think they ever got an answer. They also reached out
weird.
They also reached out to all the countries that had citizens on board the plane, and they said, please check into your citizens and tell us if any of them were somehow weird, if there was something sketchy about them. And everyone replied except Russia and Ukraine. There were 2 Ukrainians and a Russian on board this plane. And there's a reasonable explanation for that, which is that these countries had just gone to war. So Russia had just invaded Ukraine, and these guys had their hands full.
Man, I want to keep going. I want to keep talking about this, but I know that we have to separate this into multiple episodes, because now you're dropping the breadcrumbs, because I hope people can understand what we're starting to talk about. But nonetheless, this mystery is a little bit closer to getting solved, because now we have an idea back in 2014 that the plane went somewhere for 6 hours, and it could be along this north-south route.
This was very, very exciting, especially, and I talked to Inmarsat scientists, and they told me, like, we were very excited because we felt like, oh my God, we are using math to solve the greatest aviation mystery. Because even back then, when it had only been 2 weeks old, it was already the craziest thing that had ever happened in terms of an air crash investigation. And so they were like, this is amazing. We have used math and we are incredibly clever, and look at us, aren't we good? All we need to do is figure out, did it go north or did it go south? Is there some way we can break the symmetry? And that took a little bit longer, and we'll get into that, I guess, in the next episode. But I do worry that what I've been talking about today is a little A little bit abstruse. I think if people watch the video version of this, we'll put up some graphics that will help make it clearer. And if people still have questions, definitely feel free to drop a question, in comments on the show page, on the YouTube page. Reach out to us. We want to make this clear to you.
Yeah, and I'm not going to say that you're obsessed with this mystery, but you've spent the last 9.5 years of your life thinking about it. And I've spent quite some time thinking about this. So it makes sense to me. It makes sense to you. Because this isn't a live podcast, we honestly don't know if it's making sense to the viewer and to the listener. But that's why we're filming these a week in advance. So we have some time. And if something seems confusing, we'll break it down in the next episode. The next episode is even a little more crazy because there's another set of metadata out there. Right, Jeff?
Yeah, it's a little bit even more difficult to explain, but we'll have more images and we'll try to take it real slow. We might break that into two. There's a lot of things to be said. I feel like the whole point of this podcast is to take everything slow and to try to just work through everything step by step. But there's just so much to work through that, we're having to abbreviate a little bit. So hopefully.
But not too much. I mean, unlike Don Lemon, I'm sure he's a nice guy, but you just can't get into this granular level of detail in 2 minutes on a primetime cable news segment. And we're in no hurry. We'll take
even on
Netflix,
even on Netflix, 3-episode show. It's like I could only really, skim the surface. So this is
I didn't really get it until I read your book, to be honest with you.
Well, and then we were talking about it, and I was talking about the Inmarsat data, and you're like, oh, now I get it. You were like, oh, that's unbelievable. I didn't get that before. And so hopefully...
I thought I got it, but when we walked down the street in the Bronx and you really explained it to me, I was like, now I get it. And that's what we're going to endeavor to do for the audience.
I really want people to get it because it's really amazing if you have it explained to you. It's an unbelievable story, but very few people have been able to take the time to have it, to get walked through what happened and all the incredible twists and turns that happened and how the mystery unfolded and how people thought they'd solved it. The thing that people need to realize is that at this point that we are right now, it's still very early stages, but already the Inmarsat scientists were looking at this, like, oh my God, we've done it. We have solved the greatest mystery of all time. And there are many, and it's now 9.5 years later, and the plane still isn't found.
Yeah.
But people were so excited.
If you fully understand this, then you can brush aside some of the conspiracy theory talk because, again, it's data. And the more you understand, the closer we get to finding out what really happened to this plane.
There are many people whose entire worldview and theories of MH370 depend on all of this data just being fake. Just being fake. And I'm saying, if you look at it, actually, it's kind of like DNA. It's like you might just think DNA is fake, but if you look at DNA and understand how it works, it's kind of amazing. It's complicated, but it's amazing, and it's very explanatory. So I think it's worth a dive into it. Okay, that's all we have for you today. If you enjoy the show, you might well be interested in the second season of the podcast, Finding MH370, which builds upon what we learned in this first season of the podcast and uses it in pursuit of the goal of actually finding what happened to the plane. It's very much a living case. We have plans to collect new data, and if you want to help out, there's all sorts of ways that you can pitch in. So be sure to visit us at findingmh370.com. For now, this is Jeff Wise signing off by saying, don't stop looking and don't stop asking hard questions. See you next time.